this hand calculation video, we're going to be running a chi-squared test of independence. So we have patients that were randomly either given a drug treatment or placebo, and then we saw if there was any improvement in their symptoms. So let's start by writing our hypotheses. The null hypothesis is just going to be the statement that these variables are indeed independent. So treatment group and symptom status are independent, is our null, meaning there is no difference. And the alternative is that these two variables are in fact not independent. So treatment group and symptom status are not independent. So the first thing we're going to want to do is calculate the expected counts for each cell in our contingency table. And to do that, we need to get the row and column totals from our actual observed counts. So we're just going to add up the column totals, 18 and 19 here, and also the row totals. And we see that if we sum across these, we have 37 patients in our data set. So for expected counts, the formula to get each one is going to be the row total for that cell times the column total divided by the overall n. So what I like to do is kind of recreate the contingency table of the actual data. We have an improvement in symptoms and no improvement, and then we have a treatment and placebo. And then I'm going to use this formula here in each cell to get our expected counts. So for the treatment, yes, improvement, we are going to take that row total, which is 21, multiply it by that column total, which is 18, and then divide it by 37. So we get the expected count for that cell is 10.22. I'm just going to repeat that process for the other three cells. So at this point, we want to check and make sure that our assumptions of the test are met. So our sufficient sample size assumption says that all expected counts are greater than 1 and at least 80% are greater than 5. And here we see that all counts are greater than 5, meaning that we meet the sample size assumption. So we can continue on with our chi-squared test. And the next step would be to calculate our actual test statistic, chi-square, which is equal to the sum of our observed minus expected counts squared divided by the expected counts. So again, we're going to be applying this formula to each of our 4 cells of the data. So I'm going to copy another blank contingency table down here. And for each cell, I'm going to go in and find their observed and expected counts and just plug it into this formula. So for the treatment yes group, I had 13 actual patients, and I expected 10.22. So this chi-square is going to be equal to 13 minus 10.22 squared divided by 10.22, which is 0.76. And I'm just going to repeat this for the other 3 cells. So our chi-squared test statistic is just going to be the sum of these 4 numbers. So if I add them up, I'm going to get our chi-squared test statistic of 3.42. Now in order to make a conclusion about the null hypothesis, I need to compare this to the critical value for this test. So the critical chi-square, we need a degree of freedom. And for a test of independence, that's going to be the rows minus 1 times the columns minus 1. So we have 2 rows and 2 columns. So that's just 1 times 1, which equals a degree of freedom of 1. And at alpha 0.05, our critical value is 3.84. Therefore, our conclusion, since our chi-square is less than the critical value, we will fail to reject the null hypothesis that treatment group and symptom status are independent.